Mark Schoennagel here from Autodesk, and what I want to show you in the next 20 or 30 minutes is really just some more of the advanced things that you can do with the Lagoa tool set found with inside of ICE, all in the 2011 Advantage Pack version of Softimage. And really before we get into the fun of all this, I want to show you something I find pretty incredible. It's the new beta of the Arnold rendering engine from SolidAngle. They were kind enough to let me show that all off to you today, and I've been talking on my blog about giving you a little teaser of that. So check this out. We've got I got a little cup here that's been shattered, and it's kind of hard to see because, well, it's in shaded view right now, and there's 3 million spheres on the screen right now. Watch this. I'm just going to draw a render region by pressing the Q key, and I can't even finish talking yet. It's done. That's 3,200,000 spheres that pretty much just began rendering instantly. And again, this is the Arnold rendering engine. It's in beta right now. It behaves and looks very similar to Mental Ray, the way it works with inside of Softimage, the render region, the render tree. All that works. We're not going to talk about that too much, but it is pretty amazing to render your Lagoa simulations with this. I'm just went full screen there and check that out. Here I can spin the camera around. We can see this really nicely. And let me look at this from the back side. And you can see it's extremely interactive. Make a change. You know, if I tune the colors, whatever, it all updates immediately. So I'm using the ambient occlusion shader right now, which I think looks really cool with all these spheres. And I'll show you a few little animations I've done here in a second. And then we'll talk about how we got them. So this is just a cup, just a piece of geometry, and I threw the, in this case, the highly shattering or highly breakable Lagoa material, and we get this effect, we get this result. So this is about 90 frames into the simulation. I've got a nice rendering I can show you, but I just wanted to show you the speed that that Arnold has. I just find this absolutely amazing. So pretty cool. Whether or not you have depth of field on, motion blur, it all happens this interactive. So really good stuff coming out real soon from the guys at SolidAngle. So just wanted to give them props for that. But before we take a look at some of the stuff that we're going to do between Maya and Softimage, let's just take a look at a couple videos. So I'm just going to run this, and just to show you some of the things that we're going to be talking about today. This is actually the scene that I've been rendering in front of you. This is the same cup, only animated, and you can see it really just fractures into thousands and thousands of pieces. Same shot again, just a bit closer up. It's really just amazing to see all those little tiny spheres just interconnected with one another, all reacting with one another. This shot here is probably my favorite, I think, of this scene. Just look at the tearing that you get there in the top of the cup. You really see how well the fracturing happens. And here we've got depth of field on, so you'll notice there's blurring in the foreground and background. Here's a mouse trap. I whipped up one late one evening. I thought that'd be fun to simulate, and that's just over an evening to simulate all that. Here's a top-down view of the same shot. It's just, if you like blowing things up, you'll have a lot of fun with Lagoa. And here's, if you don't like blowing things up, you can turn things into Jello. So that's a cool little Jello cup, which was my first test, actually. So just going to go back to Softimage, and let's start this demo off. So just going to go close this up. Let's get things ready by getting a new scene. And we'll just say no to saving that. And because this is all about Maya interop, I'm actually going to start off by going down here and just firing up Maya. And let's talk about how we can get some of that data, just like Lee did, back and forth from Maya into Softimage. Alright, so to get started, we're just going to have to load up some geometry, or get a sphere or a cube or a torus, whatever. I've got a scene I've already set up here, which is just the cup, just like we saw before. And now I want to pass this over to Softimage. So before I can do that, I need to go ahead and create a camera. So I'll just go here to create camera, and you can see it appears there in the middle of the world. And then just select all the objects that you're interested in passing over to Softimage. In this case, the cup, the grid, and the camera. And then File, Send to Softimage. So here we got Send to Softimage. It's a new scene. Update the current scene. Add it to the scene. I'm just going to tell it, hey, you know what? I want a brand new scene in Soft. And it's just automatically, without me touching the mouse, without me doing anything, it's just automatically going to either launch Softimage if it's not already open, or if it's open, just toggle me into it and create a new scene, and then load the geometry that we were working with inside of Maya. And now you can see also down here, update, that I am in fact connected to Maya. So now anything that I do, I can send back. So first go ahead and select the object that you want to be Lagoa emitter, or the particle emitter. In this case, it's going to be the cup here. And then I'm going to click on the word ICE, and particles, create, and this gives me a list of different types of particle presets we have. Our basic particles, we have cigarettes, fires, things like that. For Lagoa, you can see we have some other different types of materials down here. And these behave quite a bit differently. So these are all presets. You can change these. There's quite a lot of tuning you can do. I'm just going to go ahead and start by using Jello. So click on Jello, And now you'll see that the mouse says pick. So it's asking me to pick a collision obstacle. So I'm just going to select the grid, and I can see I get an hourglass while it assigns ice trees to both the grid and the cup. So just like that, I'm just going to move this out of the way and press play. I've got myself a little basic simulation already. Not too many particles there. I'm just going to put this in loop mode. And it also brought up this property page, which corresponds to this compound here of all the parameters that I can tune. And you'll notice that every single one of these words here match a word here, because every one of these parameters can be overwritten by other compounds or nodes, and we'll see that in a little while. But basically, this whole property page is generated by what we see here. Probably getting a little too deep right now, but check this out. If we so we want to make the simulation have smaller spheres here, or more particles. I'm just going to reduce the resolution count, and now we'll get smaller spheres, which will then, of course, increase the number of spheres in the screen. And these can be spheres, they can be cubes, they can be points. I just like to have them represented, and by default, they're represented as spheres. So we can start to tune some of the parameters. I like to do extreme values when I'm just kind of working with it at first, just to see what those values do as I get more comfortable with the values. You can see the stretch resistant makes it quite a bit less, well, it doesn't stretch as much, so it gets a bit more bouncy there, holds its volume a little bit better. Because it's hollow, it doesn't hold its volume like it would if it was solid, but you get the idea. You'll also see the substeps down here. I'm going to bump this down to, say, 0.5 or maybe a little bit lower. And it's possible that we'll see these spheres. You can see there's quite a few of them now. This might actually go through the floor, or it might just break all apart once it hits the ground. Yep, just like that. I was kind of anticipating that. And the reason for that is the substep count. So we can increase that. The more substeps, the longer the simulation takes, but it will give you a more accurate result. This gives you a really good look at what it's gonna be. You can see it's definitely holding its shape nicely, and that looks pretty cool. So we could actually send this right over to Maya right now. So you know what? Let's go ahead and do that. So I'm going to stop the simulation, and I'm just going to press the update button. Now this will take a minute or so. Well, you can see the progress bar. This will take a minute or two to cache, so I'm just going to pause the video, and when we get back, we should be back in the land of Maya with our Jello cup. All right, gonna increase my frame amount here. Press play and check it out. There's our cache simulation. Obviously, it's running a lot faster now than we saw in Softimage because it's cached and it's not actually having to simulate that. But hey, check it out. There's a Lagoa effect right back inside of Maya. So let's go ahead and stop this, and let's go back to Softimage, and let me show you a couple of the neat things. Now, all of these parameters right here, there's really not that many of them. There's a heck of a lot more values that you can tune within the Lagoa framework than we see in this exposed preset right here for Jello. So let me show you a neat little trick. Let me bump this back up to something like 0.7 or so, and bring my substeps down just a bit so we can get a little faster simulation. I'm only using a quad-core laptop. Even that rendering that I showed you earlier, that was all just done on this nice quad-core HP laptop I have, so I'm not using some monster 12-core workstation, by the way. But check this out. I want to go and tune more than just the parameters that are available here. So what I'm going to do is I can press the E button, so I'm just going to click on that, and that will actually take me inside of the compound. So all of these nodes here, and some of these are compounds as well, this is really what makes Lagoa work, and each one of these has quite a few more parameters that you can tune and change than we had before when we were outside the compound. So what a compound really allows you to do is take a bunch of nodes, like we see here, and just expose the parameters that we're interested in to the outside world, to the user who's going to eventually use this tool. So in fact here, if I wanted to add maybe enable gravity or enable air density to this, I can just grab these little lines and connect them, and that will enable them, and you can now see those here inside the property page. Or if I said, I want to get the wind direction, that adds a vector. So you can see for every type, which is these little colored dots, it adds a different type to the property page here. So all this is dynamic. I know it's getting a little bit ahead of myself, but I just wanted to explain what all these little lines there, so it wasn't so confusing if you just saw this for the first time. Well, the other thing you can do is close that up, and instead of diving into the compound like that, what I generally do, especially when I'm working with these Lagoa presets, is to just do what we call explode the compound. So I'll click on explode compound, and that basically removes the hierarchy or takes you one level above it, and then it gets rid of all those ports, makes it a little bit easier to see. Pressing Control R will rearrange any ice graph and make it a little bit more presentable when you've got nodes that are either on top of one another, or if you just did a bad job of laying it out, it'll do its best to fix that for you. So let's take a look at what's in the compound. This is where you really get into the really the heart of the Lagoa system, and ICE as well. So I'll just go full screen here and just show you the whole graph in its entirety. Now all this was set up as a preset when you did the ICE create Jello. What that did is it took the emitter, the cup. This is the nodal representation of the geometry of the cup. It creates the Lagoa emit volume. If you double click on that, you can see we have quite a few more parameters than we did before. We had resolution, of course, available. We didn't have things like, just simply changing the shape to a sphere or to a box or to a rectangle. And that can be instance geometry. You could have 1,000 little people as representing each one of your Lagoa nodes. And some other parameters in here, which I can talk about later, but really some other important stuff. Lagoa add forces. It has its entire whole force system built within inside of it. But you can still go over here and type, say, the word force and use any of these forces that are available in ICE in general. Can be used with Lagoa as well. The Lagoa phase node, I'm not going to get into this today. I'm going to have a much more in-depth look at this on my blog here in a few weeks. But what this allows you to do is say, after 30 frames, I want you to go from jello to water, or from foam to dust, or something like that. You can have all sorts of different triggers, time, events, things like that. It's really almost like a state machine. But really, probably the most important node is this guy right here, the Lagoa material. And right now we've got the jello preset on there. If I double click on that, these are all the preset values, the parameters that make jello behave the way it does as a piece of Lagoa material. So we're solving for pressure, we're solving for elasticity, but we're not solving for things like viscosity, inelasticity, and those are all things that are available in the Lagoa framework. So if you go over here back to your search tool for the ICE tree and type in the word material, you can see all of these different Lagoa materials appear. And really, all of these are just subsets of this guy right here. If you bring the main Lagoa material in, this node right here basically will recreate and can recreate all of these effects right here. These just have different presets and exposed parameters. So for instance, jello, if I open this guy up, you can see we still have pressure, but viscosity is turned off, inelasticity is turned off. So what we've done for the jello preset, if I go into the compound like I showed you before, we only expose a few parameters. We don't expose the viscosity settings, we don't expose the inelasticity setting, so that you get a much smaller compound than the main material, and it only shows you just the parameters that are important for jello. And this is really cool, because if I go back here to kind of half screen, I can have all these different material presets, which again are just presets of these guys, of this guy right here, the main material. So for instance, if I were to take the jello material and replace it with, say, highly breakable. Check this out. We're just going to move this, rearrange it, and I can do this while the simulation is running, no problem. Plug this in. The next time this falls, this will become a highly breakable Lagoa object. I can increase my steps or my count a few, and this will wait until the next time it simulates before we see the spheres become smaller. Should be a little bit neater effect. There you go. I could make it, let's say, liquid water. Let's grab this guy and plug that in. Get a little bit more room here. And all I'm doing is replacing the main Lagoa material. So there's a splashy water. So very cool. All of these things are very interchangeable. And again, they're all just presets of the main material. So you don't really, once you learn Lagoa, you don't have to use any of these presets if you want. Just use the main material and tune it from there. But with these different materials, you can do all sorts of fun things. And one thing you'll notice, especially here with the liquid water, it's behaving like liquid and flowing across this surface, the collision obstacle, quite a bit. If we refresh the ICE tree with the grid selected, when I started the whole process and I selected the cube, I went through the ICE, create, and then it did jello, it told me to pick the collision obstacle. So I picked this object here. And what that did is it assigned this node in this Lagoa, or this ICE tree, to the grid. If I double click on this, I have a few parameters here that I can also set. And this is where I can control things like friction, slipping. So right now you can see the spheres really slide quite a bit along the surface there. if I crank up the static, check that out. Now the friction is quite high, and they're just going to basically stop. And all that's keyframeable, of course, too, but that's where you would tune that type of setup. So I'm going to crank that down a little bit more, and let's go back and look at some of the jello stuff, or some of the liquids and some of the other materials. So let's go back and play with a couple other of these. Let's get rid of the, just stop this for a second, get rid of the water. I'm going to put highly breakable back on. And notice what happened when I deleted that material. This turned red, just told me, I'll undo that, just told me that now something's no longer working correctly. You've somehow gotten rid of a major component. So do that again, turns red, plug this back in, hey, everything's back good again. So let's go ahead and try a couple different materials. Let's delete highly breakable, and let's delete the jello, and let's go ahead and get some liquid water type material here. Let's grab this guy, plug it into here, press play, and this should give us a nice kind of a splashy water look like that. Great. We had some of that surface on there. Now you might be wondering, geez, can I turn this into real geometry? Absolutely. So what you would do, select the particles, or any particles really. It could be Lagoa, it could be just a standard particle emitter. Select all your particles. Just go to Particles, Create, and we want to do a surface from point cloud. And look at that. That automatically then becomes a real piece of geometry that you can render out. You can do whatever you want to do to it. You can see it's dynamically adjusting. It's growing, it's shrinking as the simulation is running. I'm going to go ahead and just stop the simulation. Oops, let that simulate out a bit. Again. Actually, one thing I should point out, you'll notice I only have a few particles in my scene, so I've got this kind of a hole right there. Actually, that's a good thing. Let me show you this real quick. Hide that. So we didn't see that quite clearly when they were just particles, but when I turn that to geometry, you can see there's a kind of a big hole there. The reason for that is under the emit volume, there's a parameter that when you're using objects kind of like, well, it could be a lot of different objects, but in this case, we've got a very thin lip on the cup. So if I want to make sure that I get a nice uniform placement, even where maybe these spheres aren't big enough to fit, you'll want to check these two boxes, or just see the difference here. If I click on the fill space, it'll make sure that it fills all those gaps, but then it could introduce larger spaces than it normally would in between the regular particles, which sometimes is the effect you're looking for, and sometimes it's not, which in this case it is, so that's perfect. Now we can go ahead and unhide let's unhide our polygonized geometry, and there it is. This is the geometry we just created. Now you can see it's a nice surface. The more particles we had, the smoother that could be. But now you can see we've got kind of a cool cup that turns the liquid. And I'm just going to pause it there for a second. A few things in here. When you activate the polygonizer, you get a few parameters here that you can change. I can increase the ISO level or increase the detail. This obviously does just what it says, increases the detail. And if you're doing any types of a liquid, another thing I would recommend is once you attach the polygonizer, go back to ICE, Create, and add the Lagoa Fluid Shaper. And that'll just give you a bit more control over how this looks. And trust me, you'll get a much better look to doing fluids when you use the Fluid Shaper. And then, of course, what you would do is hide the particles so they don't render. Maybe I've got those a bit too pointy like that, and render this out, and that would probably look pretty good. So anyway, let's go ahead and delete that, and let's get back to working with just the point cloud. So there we go. And hey, you know what? We haven't done this for a while. Let's go send this to Maya. But first, let's increase the resolution to something like 0.4. Get quite a few of these. And because I'm outside of that initial compound that we had for the preset, it's important that I go and increase the substeps, and maybe inelastic substeps too, just like this. So let's go ahead and send this to Maya. So I'm going to click on Update. And before I do that, let's just go back to Maya, and you can see, hey, right there we still have our Jello cup still there. I can still scrub that and see that move around. Let's go here back to Soft, and I'm just going to click the Update button, and just going to let this cache. So I'll come back in a minute or so. All right, we're almost done, 98%. It's been just under a minute actually, and it automatically pops me back to Maya. Press play, and I've got this cool effect. And if I can remember how to orbit the camera, there we go. Check it out. So we got a pretty cool effect like that, and that honestly was just under a minute of simulation time on a 4-core machine, so it does simulate fast. let's go back into Softimage, and let's take a look at just a couple of the things. Right now we've got the liquid water. Let's get thick liquid here. This is kind of neat. And let's just overwrite this guy. Let's just go and reduce or increase our size to reduce the number of particles. And you can see we've got this kind of thick liquid that that now runs out. And if we just go back down to our material for thick liquid, let's get rid of the pouring water. I could probably turn down my substeps. I generally work with lower substeps when I'm trying to be interactive, and then when I'm actually simulating for real, I crank the substeps up. But here you can see that we obviously have a lot of surface tension. So watch this. If you release the surface tension, it really becomes breakable. Increases surface tension. Well, that's way too much. And they just want to be stuck together. So you can see, just like I was, oh, that's cool. The one's kind of spinning at us. So you can see it, just like I was mentioning, you just tune these parameters, and just by adjusting something like the surface tension, we get something that's more like a breakable or a splashy water than a thick water, like so. All right, so I want to show you one more example. Just want to show you how easy it is to set up a simulation that has several objects in it, not just one or two. But let me just have one more bit of fun. Pass this over to Maya. I'll set the number to be like 0.3, make it even more than we had before. And again, just like I did, I'm going to increase the substeps here. Let's just crank this up to, say, 4. I'm going to pass this to Maya one more time, and then we'll do one more thing. All right, so it's finished. It took, well, I was able to pour a cup of coffee and add the sugar, but I got no cream in the cup. So that's how long it took this to simulate. Anyway, pretty cool. There's some thick liquid splashing around inside of Maya. Just a couple minutes of render times, of simulation time. So good stuff. Do want to show you one more thing, which is just how you would set up a simulation with several collision obstacles. So just going to go ahead and stop this for a second. Let's go in here and let's get a new scene for Maya. Let's also just refresh Softimage, and we'll get a new scene inside of Soft as well. And let's just go back here to Maya. We'll do a file, open recent, and I've got a little sync set up here where I have obviously quite a few more objects, and I'm just going to grab all of these, and we're going to send these to Softimage just like we did before. Send to Softimage, send as a new scene. Pops us right back into Softimage. And for this guy, because we have a lot of obstacles, we need to create a group. So I want you to turn on your main command panel, which are these 3 tabs here at the bottom. So click MCP for main command panel, and we basically need to create a group of all the collision obstacles. So just select everything in here. Now I've got this. I should just do them one at a time. The faucet. I don't want this object here, this P cylinder. This is actually my emitter. So I'm just going to fill or select all of these up so that I can fill the sink up and have these objects collide with it. So I'm going to click on group, and that's going to create a group of all the selected objects. And then I could name this whatever. I could call this OBJs. And now there's a group. If you open this group up, all of those objects are in the group. So now if I want this object here to emit some water, I'll click on it, select ice, create, and then we want to do pouring liquid. And now, because it only allows me to pick one object, I can only pick the sink or the cup or the coffee pot here. So instead, click on your group, like so. And this is really important because this will assign to all of the objects that ice tree that will control, this guy here, the one that will control the static friction, the no slip, like I showed you earlier. So now each one of these objects, you'll be able to tune just how much friction is on there. Go back to your emitter, like we have here. And that should have our, go to your pouring liquid and just refresh your ice tree. Here's all the setup for that. If I click on play right now, we really got pretty much just a drizzle. So one thing you can do, I'm going to increase this to like, say, 500 frames or so. Let's go into the compound, and let's go ahead and check these 2 boxes here. Now let's just watch what happens when I click on these. So fill space and perform space check. So you can see there we're maximizing the space and making sure that we're filling the complete volume of the emitter. And if I were to go and select just the emitter, This is pretty cool to see. If I translate this in local space, watch as I move that thing out, you can really see how those particles are reacting with the whole environment. They're once they go inside this cylinder or inside the faucet there, it really comes out looking like water. So anyway, that's going to fill up the sink. I'll just let this update, let this simulate to Maya, and we'll take a look at that. Click on update, let this cache. All right, so that's it. Back inside of Maya, we're done simulating. Press play. We've got ourselves a nice sink filling up with liquid. So that's it. That wraps up today's webinar. Hopefully you all learned something, and hope you enjoyed some of the work that we're doing to get Max, Maya, Softimage, all of our 3 great products talking to one another to make your lives a whole lot easier.